Hi, hello, welcome back. We are moving on to the next topic, electricity and electric current. So let us get started. We all are familiar with electricity. It is the most widely used form of energy in our homes, offices, and industrial establishments. In fact, we have become so accustomed to various electrical appliances and gadgets that we cannot live without electricity even for a short time. All the electrical appliances work on electricity. So all these things we all know that, right? Electricity is the very important energy form that we are using in our daily life. So we cannot live without electricity nowadays, right? So let us see what is electric current. Whenever an electrical appliance or a gadget is actually working, an electric current flows through the appliance or the gadget. An electric current is defined as the flow of electric charge per unit time. The SI unit of electric current is ampere. Electric current is said to be 1 ampere if 1 coulomb of charge flows per second. The direction of electric current is the direction of flow of positive charges or opposite to the direction of flow of negative charge. So, what is electric current? We all know that whenever an electrical appliance is working, it means electric current flows through the appliance, then it becomes working. Okay, so an electric current is defined as the flow of electric charge per unit time. Okay, that is flow of electric charge per unit time is the electric current. The SI unit of electric current is ampere, and electric current is said to be 1 ampere if 1 coulomb of charge flows per second. That is very important. And the direction of electric current is the direction of positive charge or opposite to the flow of negative charge. Okay. Conductors and insulators of electricity. A material which easily allows the flow of electric current through it is an electric conductor. All the metals and alloys such as copper, aluminium, nickel, tin, brass, German silver, etc. are good conductors of electricity. Mercury is also a good conductor of electricity. The electric current can flow through a human body, but it is not a good conductor as metals. So, conductors are nothing but they are the materials in which they allows the electricity to pass through them. So, such materials are known as electric conductors. The examples are copper, all the metals and alloys such as copper, aluminum, nickel, tin, brass, etc. are good conductors of electricity. They will conduct electricity. Okay. So, mercury is also a good conductor of electricity, as well as we all know that we also get shock from the electric circuits, right? Why? Because we are also conductors of electricity, but not good as the metals. Okay. And next one, a material which does not allow the flow of electric current through it is called the electric insulators. Most non-metals and materials like plastic, rubber, wood, glass, oil, cotton, ceramics, etc. are insulators. Pure water is also an insulator. All gases are also insulators. Electric wires are always wrapped with rubber or plastic insulators so as to make their use in electric circuits safe. Okay, so electric insulators are nothing but they are the materials which do not allow electric current to pass through them. Okay, so they are known as electric insulators. Examples are all the non-metals and the materials like plastic, rubber, wood, glass, cloth, wool, ceramics, etc. are insulators. Important thing is that pure water is an insulator. Okay, and next one, all the gases are also insulators, and we are familiar that we all know that in our home, we can see the electric connections, right? We are familiar with the electric circuits, and the wires are always wrapped with the rubber or the plastic insulator so as to make them use in electric circuits safe. Okay. Next one is about what are the sources of electricity. The various sources of electricity are cells, batteries, main supply, generators, etc. Okay, so these are the sources of electricity. Cells. First one is the cell. The first ever source of continuous flow of electricity has been an electric cell. It is an arrangement in which chemical energy is converted into electrical energy. Due to this reason, an electric cell is also known as electrochemical cell. Okay, so the various sources of electricity are cells, battery, main supply, and generators, etc. So first category is the cells. Cells are nothing but they are the arrangement in which the chemical energy stored in them is converted to the electrical energy, and we are using in so many appliances in our daily life the cells. That is the remote, torch, watches, wall clocks, etc. We are using this cells. Okay, and electric cells are of two types, that is primary cells and secondary cells. Okay, so first one is the primary cell. A primary cell is that which once used cannot be reused. Daniell cell, dry cell, Leclanché cell, etc. are examples of primary cells. Okay, so electric cells are of two types, primary cells and secondary cells. Primary cells we cannot reuse it again. Okay, once used it can be thrown away. We cannot reuse the cell. That is, they are known as primary cells. Secondary cells. Secondary cell is that which can be used again and again by recharging them. Cells used in the mobile phones, inverters and cars are examples of the secondary cells. So secondary cells are the cells in which we can use it again and again by recharging them. We are familiar with our mobile phones, right? Once the charge is less, we will again recharge the mobile phone and we are using, right? So such type of cells are known as secondary cells. Okay. Widely used in torches, alarm bells, wall clocks, remotes of TV and AC, and in many other electrical and electronic devices. Most commonly used cell is the dry cell. Let us study its construction and action. So children, we are discussing about the sources of electricity, and the first category is about the cells, and cells are of two types, primary cells as well as secondary cells. And the most commonly used cells is the dry cell. So let us study its construction and action. So dry cell. A dry cell consists of a carbon rod inserted into a black colored powder. The powder is the mixture of manganese dioxide and carbon. The powder is taken in a small muslin bag. The muslin bag is placed inside a zinc container. The space around the muslin bag is filled with the moist paste of ammonium chloride and gelatin. The zinc container is placed in a leak-proof cover or a cardboard, and the top is sealed with pitch. The zinc container acts as the negative terminal of the cell and the carbon rod as the positive terminal of the cell. Usually, a brass cap is provided on the carbon rod. When the cell is connected to an electric device, then chemical reactions take place in the cell and an electric current is produced. A dry cell gives a voltage of 1.5 volt. As a dry cell is small, compact, light and portable, so it is widely used. Dry cells are used in a variety of household gadgets like torches, electrical wall clocks, electrically operated toys, TVs and air conditioners, remotes, etc. So children, we are discussing about the construction of a dry cell. It is clear from the figure 7.7. You can see the picture of a dry cell. Okay. So a dry cell consists of a carbon rod inserted into a black colored powder. Okay. That is the first thing. And the powder is a mixture of manganese dioxide and carbon. Okay. So you can see the picture very clearly. You can see the carbon rod and it is inserted into a black colored powder. That is the manganese dioxide and carbon. And next layer is the powder is taken in a small muslin bag and it is placed in a zinc container. Okay, and the space around the muslin bag is filled with the ammonium chloride and gelatin. There is paste of ammonium chloride and gelatin. Okay, and it is taken in a zinc container, that is a leak proof cover. Okay, and the top is sealed with a pitch. So the zinc container always acts as a negative terminal and the carbon rod as the positive terminal. If we are taking a cell, you can see a positive symbol on the top of the cell and a negative symbol on the base of the cell. So it is actually a brass cap is provided at the top of the cell, and of course the zinc container will act as a negative terminal, and the brass cap, that is the carbon rod, will act as the positive terminal. Okay, so this is the construction of a dry cell. And when this cell is connected to any electric device, then the chemical reaction will take place inside the cell and the electric current is produced. Okay, so in a dry cell it gives a voltage of 1.5 volt. Okay, that value is important, so study nicely. And as a dry cell, this dry cells are very small, it is compact and light, and it is portable, so that it is widely used. So the dry cells are used in variety of household gadgets also. Okay, so like torches, electric wall clocks, electrically operated toys, TVs and air conditioner remotes, etc. Okay, so these are the applications of dry cell. Okay, batteries. A combination of two or more cells is called a battery. You must be familiar with your car battery or inverter battery. To form a battery, the negative terminal of cell 1 is kept in contact with positive terminal of cell 2. The negative terminal of the cell 2 is kept in contact with the positive terminal of the cell 3, and so on, as shown in the figure 7.8. The appliance with which battery is to be used is connected between the positive terminal of first cell and negative terminal of the last cell. This arrangement of grouping of cell so as to form a battery is called the series grouping of cells. So children, battery is nothing but it is the combination of two or more cells. Okay, so in this way, that is the figure shown in 7.8 is the battery consisting of three cells, and it is called the series grouping of cells, in which the negative terminal of the first cell is kept in contact with the positive terminal of the second cell, and the negative terminal of the cell 2 is in contact with that of the positive terminal of the cell 3. So this is the arrangement. So this type of arrangement or grouping of cells is known as the series grouping of cell. Okay. Next one is about main supply. We draw electricity from main supply in our homes. A huge amount of electricity is produced in power plants and then distributed through a network of cables to different areas. This electricity reaches the mains in our homes. From the main supply, an electric current is supplied to various points provided in the rooms. All electrical appliances used by us are connected to these points. So children, we all know that main supply is the another source of electricity in our home. So we draw electricity from the main supply in our homes. Okay, so any one of the switches or the main supply is getting tired, and we cannot work the appliance in that particular gadget or the appliance. Okay, so a huge amount of electricity is actually producing in the power plants, and it is distributed through various places through the cables. Okay, so this electricity reaches the mains in our home. Okay, from the main supply we are using the electricity in order to work different appliances in different rooms in our home. Okay, next one is generators and inverters. Whenever main supply is off due to power failure, generators can be used to supply electricity. Nowadays, inverters are used in homes and offices for uninterrupted power supply. So generators are another source of electricity in which whenever the main supply is off due to the power failure, so we will use the generators in order to provide the electricity. Okay, so nowadays we are using the inverters in order to use the appliances from power supply. Okay, and next one is about solar cells. A solar cell is a special type of cell which directly converts the light and heat energy received from the sun into electricity. As power of a single solar cell is small, generally a solar panel is designed which consists of a large number of solar cells connected in series. Consequently, we can get more electrical energy. Earlier, solar cells were considered costly, but with the advancement of science and technology, cost of constructing solar cells has become quite less. As a result, solar cell panels are considered to be a good source of electricity. Okay, so last one is the solar cells. Solar cells are also a type of cells in which it converts the light and heat energy that is received from the sun directly to the electrical energy. So as the power of the single solar cell is very small, so we are using, or it is designed in a solar panel which consists of a large number of solar cells connected in series. So consequently we get more electric energy. Earlier it was so costlier, but with the advancement of science and technology, the cost of constructing solar cells has become quite less. As a result, solar cell panels are considered to be a very good source of electricity. So children, this is for the class. In this video, we have discussed about what are the different sources of electricity, that is the cells, batteries, power supply, then generators, solar cells also we have discussed. So everyone please go through the channel and go through the videos, textbook, read nicely, understand the concepts, and thank you. Keep watching. Keep safe in your home. Thank you.